Hello children, let us see modulus equations and modulus inequalities. First we will see modulus equations. First question, solve for x. Mod x minus 1 is equal to 2. Recall the definition of modulus function, that is fx equal to mod x. Fx is equal to x if x is greater than 0 and fx is equal to minus x if x is less than 0. So applying this definition, in this case, mod x minus 1 is equal to x minus 1 if x minus 1 is greater than 0 and mod x minus 1 is equal to minus inside bracket x minus 1 if x minus 1 is less than 0. In other words, first step is to find out the critical points. So x minus 1 is equal to 0 or x is equal to 1 is critical point. Critical points are those points where function changes the sign. So at x equal to 1, this function mod x minus 1 changes the sign. So accordingly, we will consider two cases, when x is greater than 1 and when x is less than 1. First case, when x is greater than 1. So mod x minus 1 will be written as x minus 1. So x minus 1 is equal to 2 or x is equal to 3. We will check whether x is equal to 3 is solution or not against this condition. So x is equal to 3, whether x is greater than 1? Yes. So this is solution. Second case, when x is less than 1. So mod x minus 1 will be written as minus x minus 1. So minus x minus 1 is equal to 2 or x is equal to minus 1. Again, we will check whether x is equal to minus 1 is solution or not against this condition. So x is equal to minus 1, whether x is less than 1? Yes. So this is another solution. So there are two solutions, x equal to 3 and x equal to minus 1. So we can write it as x belongs to these 2 points, minus 1 and 3. Second question, inside mod x minus 1 plus 1 is equal to 4. We will consider inner mod first. Critical point for this is x is equal to 1. So we will consider two cases, when x is greater than 1 and when x is less than 1. When x is greater than 1, mod x minus 1 will be written as x minus 1. So it will be within mod x minus 1 plus 1 is equal to 4. When x is less than 1, mod x minus 1 will be written as minus x minus 1. So it will be within mod minus x minus 1 plus 1 is equal to 4. Now consider this case first. For x greater than 1, mod x minus 1 plus 1 is equal to 4. So mod x equal to 4. For x greater than 1, mod x will always be equal to x. So x is equal to 4. Now check x is equal to 4 is solution or not against this condition. So x is equal to 4, whether x is greater than 1? Yes. So this is one solution. Second case, when x is less than 1, mod minus x plus 1 is equal to 4 or mod minus x plus 2 is equal to 4. Now this is our condition, x is less than 1. So x is less than 1. For x less than 1, mod of minus x plus 2, this will always be positive. So it will be written as mod of minus x plus 2 as minus x plus 2 is equal to 4 or x equal to 2 minus 4 or x equal to minus 2. So let us check whether x equal to minus 2 is solution or not against this condition. So x is equal to minus 2, whether x is less than 1? Yes. So this is another solution. So there are two possible solutions, x is equal to minus 2 and x is equal to 4. So we can write it as x belongs to these 2 points, minus 2 and 4. Third question, mod x plus 1 plus mod x minus 1 plus mod x minus 5 is equal to 4. Critical points will be x is equal to minus 1, x is equal to 1 and x is equal to 5. So we will consider the cases when x is less than minus 1, when x lies between minus 1 to 1, when x lies between 1 to 5 and when x is greater than 5. So let us consider all these cases one by one. When x is less than minus 1, all of them will be negative. So we will write it as minus x plus 1 minus x minus 1 minus x minus 5 is equal to 4. That gives x is equal to 1 by 3. So we have to check whether this is solution against this condition. So x is equal to 1 by 3, whether x is less than minus 1? No. So this is not the solution. Second case, when x lies between minus 1 to 1. This will be positive, these will be negative. So we will write it as x plus 1 minus x minus 1 minus x minus 5 is equal to 4. This gives x as x equal to 3. So x is equal to 3, whether x lies between minus 1 to 1? No. So this also is not the solution. Third case, when x lies between 1 to 5. So these two will be positive and this will be negative. So x plus 1 plus x minus 1 minus x minus 5 is equal to 4. This gives x as x is equal to minus 1. Let us check against this condition. So x is equal to minus 1, whether x lies between 1 to 5? No. So this also is not the solution. Fourth case, when x is greater than 5. So all of them will be positive. So x plus 1 plus x minus 1 plus x minus 5 is equal to 4. This gives x as x is equal to 3. Let us check against this. So x is equal to 3, whether x is greater than 5? No. So this also is not the solution. So we didn't find any solution in any case. So there is no solution. So x belongs to 5. Now let us see modulus inequalities. Modulus inequalities are solved the same way as we solve modulus equations. These are 4 formulas related to modulus inequalities. Sometimes we may apply one of these formulas to reach the result in one step. For example, suppose we have to solve mod x minus 1 is less than 4. So this matches with first one and the result is x will lie between minus a to plus a if a is greater than 0 and x will have no solution if a is less than or equal to 0. In our case, x is x minus 1 and a is 4. So we can apply this result and we can say that x minus 1 will lie between minus 4 to plus 4 or x will lie between minus 3 to plus 5. So we have reached the result in one step. However, we can reach the same result in few more steps by our usual analytical approach. Fourth question, mod x minus 2 plus mod x plus 3 is greater than or equal to 5. First step is to find out critical points and they will be x is equal to 2 and x is equal to minus 3. So we will consider 3 cases when x is less than minus 3, when x lies between minus 3 to 2 and when x is greater than or equal to 2. First case, when x is less than minus 3. So both of them will be negative. So we will write minus x minus 2 minus x plus 3 is greater than or equal to 5. So we will reach here. X is less than or equal to minus 3. We will check this solution against this condition which is true. So x less than or equal to minus 3 is one solution. Second case, when x lies between minus 3 and 2. So this will be negative and this will be positive. So minus x minus 2 plus x plus 3 is greater than or equal to 5. That means 5 is greater than or equal to 5, which is true when 5 is equal to 5. So this also is one solution when x lies between minus 3 to 2. Third case, when x is greater than or equal to 2. So both will be positive. So we will write x minus 2 plus x plus 3 is greater than or equal to 5. That means x is greater than or equal to 2. We will check against this condition, which is the same. So this is also one solution. Now combining all 3 solutions, this and this, we can say that x may be any real number. Fifth question, mod of x minus 1 upon x plus 2 is greater than 2. We will see 7 properties of modulus in a moment. One of them is mod of a upon b is equal to mod a upon mod b. So we will rewrite this as mod x minus 1 upon mod x plus 2 is greater than 2. Now cross multiply. So it will be mod x minus 1 is greater than 2 times of mod x plus 2. Change the sign, it will be mod x minus 1 minus 2 times of mod x plus 2 is greater than 0. Now the critical points will be x equal to 1 and x equal to minus 2. So we will consider three cases when x is less than minus 2, when x lies between minus 2 to 1, and when x is greater than 1. Case 1, when x is less than minus 2. So both of them will be negative. So we will write minus x minus 1 minus 2 minus x plus 2 greater than 0. So this comes out to be x is greater than minus 5. Now this solution and this condition, when you combine, the solution comes out to be x belongs to minus 5 to minus 2. Second case, when x lies between minus 2 to 1. So this will be negative, this will be positive. So we will write this as minus x minus 1 minus 2 x plus 2 is greater than 0. So this comes out to be x is less than minus 1. Now when you combine this solution and this condition, x comes out to be x belongs to minus 2 to minus 1. Third case, when x is greater than or equal to 1. So both of them will be positive. So we will write this as x minus 1 minus 2 times of x plus 2 is greater than 0. So this comes out to be x is less than minus 5. Now this solution and this condition doesn't match because the condition says x should be greater than or equal to 1 and solution comes as x is less than minus 5. So no solution in this case. So final solution will be a combination of this solution and this solution. Now we can say that x belongs to minus 5 to minus 1, excluding these 2 points. There are 7 properties of modulus. For any AB which are real, first property, mod of A is greater than or equal to 0, means mod of any number is always positive. Second, mod A is equal to mod of minus A. Third, mod of AB is equal to mod A into mod B. Fourth, mod of A by B is equal to mod A upon mod B. This property we have just used. Fifth property, mod of A plus B is less than or equal to mod A plus mod B. Sixth property, mod of A minus B is greater than or equal to mod A minus mod B. Last property, mod of mod A minus mod B is equal to mod of A minus B if and only if AB is greater than or equal to 0. In next video, we will see logarithms. If you have any question, you can ask me on my Discord server. If you have not subscribed my channel yet, please do so.